So these are the answers to the 15 questions for Test Prep 2. Mark it for yourself and then skip along to the video where you need to. Okay, good luck. So question 1 says find the probability of getting at least 2 heads. Well, the probability of at least 2 heads is going to be equal to the probability of 2 heads plus the probability of 3 heads, because we know that at least 2 means 2 or more. So sometimes the best way of doing this is by a tree diagram. That's the first toss. Then for the second toss, we've got heads and tails again. And then for the third toss, because we're tossing it 3 times, we've got head or tail again, head or tail again, head or tail again. So altogether you'll find there are 8 outcomes. And all you got to do now is go along each one. So if we do this one, and this one, that will be head, head, head. The next one will be head, head, tail. Next one will be head, tail, head. And the last one there will be head, tail, tail. So that's those 4 there. So what we've done is these 4 here. Taking care of that. And now we're going to move on to the next one, which is going to be along here. So we got tail, head, head. Tail, head, tail is the next one. Tail, tail, head. And tail, tail, tail. And all we've got to do now is count the ones that have got 2 heads or 3 heads. Well, there's one with 3 heads. Let's do a different color. So there's one with 3 heads. There's one with 2 heads, so both of those are good. Another one with 2 heads there. This one's got 2 tails. Fourth one there with 2 heads, and the others are not the same. So 4 of them have 2 or more heads, and of course there's 8 outcomes altogether. 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 1 out of 2. Question 2, find the probability of rolling the dice twice. It doesn't say that. Now, what you've got to do on a quiz or test is replicate this chart here. So I'm going to do it very quickly for you. So on a test, you can do it quickly. And that is basically we roll 2 dice. Let's call a red one and a blue dice. And we're looking for the sum. So 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4, 5, 6, 7. 2 plus 1 here. Let's get 2 plus 1 is 3. 4, 2 plus 2, 5, 6, 7, 8. So it just 3 plus 1 is 4, 5, 6, 7, 8, 9. So it takes you about a minute or so just to sort of replicate this chart. And 5 plus 1 is 6, 7, 7, 8, 9, 10, 11, and then 8, 9, 10, 11, and 12. This is just adding these numbers up here with these numbers down here. And the question says, what's the probability of sum of 5 or below? So we're looking for all the numbers on this chart that are 5 or below. So here's the 5s here. There's 1, 2, 3, 4. Then we've got the next ones that are 4s, 5, 6, 7, 8, 9, and then 10. So 10 of them all together. This little group of cluster of numbers here, 10 results will be 5 or below. Now, how many results are there together for 2 dice? Well, if you count all of them, 6 by 6 is 36. So it's 5 over 18, which equals 27.8%. It's 27.777 repeating. Question 3. a bag contains red. We've got 5 red, 3 blue, and 2 green. And the says the probability of blue, 2 blues. So 2 blues. So the probability of the first blue is going to be 3 out of 10. And it talks about no replacement. So there's 2 blues left now for the second choice. And we know there's 9 marbles altogether. So 6 divided by 90, which if we divide, it comes 2 over 30, which I think is 1 over 15, which equals 0.066, which is 6.7%. Question 4 should be easy. The probability of rain equals 30%. The probability of snow equals 20%. And we want the probability of neither, i.e. something else happening. So it's going to be 100 minus 50, minus 30 minus 20, which equals 50%. Okay, question 5. If you draw 3 cards at the same time from a standard deck of cards with probability that both, this should actually read that 3 cards are red. So the probability of 3 red cards, you take the first one out. Well, it just says select 3. It doesn't talk about replacement. So we can actually say, well, there's 26 red cards, and we're choosing 3. All right, 26 red cards altogether, and we're choosing 3. Divided by there's 52 cards altogether, and we're still choosing 3. So this is the ways that can happen of the event that we're interested in. We want 3 reds. And this on the bottom is all events. So that's the way probability works. The number of events divided by the number of all the events. And this equals, it's 0.117, which equals, and it's a 6 after the 7, so it's actually 11.8%. Question 6. So you draw 3 cards from a standard deck without replacement. What's the probability of all 3 face cards? So basically, you want 3 face cards. Now, because we are talking about replacement, we're going to do it slightly different. And that is, well, there are 12 face cards, Jack, Queen, King of each one. And there are 52 cards altogether. So that's the probability of choosing a face card to begin with. Now, the fact that it says no replacement, it says no replacement there, means that we take that card and put it in our pocket, for instance, and now we know for the second choice there's only 11 face cards left and 51 cards altogether. And then for the third choice of card, we know there's 10 face cards left and 50 cards altogether. And that equals 0.0099, which I think is about 1% actually, because we round up every time. So question 7, you roll 2 dice, and what's the probability you get the sum of even numbers? Well, again, you'd have to use the chart, and of course the even numbers, the probability of even. The even numbers are 2, 4, 6, 8, 10, and 12. We know that 2 happens 1 way, 4 can happen 3 ways, 6 happens 5 ways, 8 happens 5 ways, 10 happens 3 ways, and 12 happens 1 way. And we just add them up, and it's all out of 36, and that gives us 8, 9, 14, 18 out of 36, which you'd expect really, because half of them are odd, half of them are even, which is 50%. Bag contains bag A, so this is number 8, and we've got bag A and bag B. So the probability of getting a red from bag A will be 1/2 for choosing red bag A, and then we know there's, and we're looking for blue, it's the probability of blue, isn't it, the question, not red. So the probability of blue marble from bag A is going to be 6/9, because there are 6 blue marbles in there and 9 altogether. The probability of blue from bag B is going to be 1/2 for choosing bag B, and then we know there are 3 marbles in bag B that are blue and 7 altogether. So this equals 6/18, which I think is 1/3, and this one equals 3/14. So basically the probability of blue from either bag is going to be 1/3 plus 3/14. And if you don't like fractions, just treat it as decimals and add them like that. And the answer is 0.547. So 0.5476 actually, which therefore is 54.8%. Question 9, if you flip a fair coin and you're looking for, and then roll the dice, looking for head and above 4, greater than 4. So the probability of a head is 1/2, and you want the probability of getting the number above 4. Well, it's the only numbers above 4 are 5 and 6, so there's 2 options out of a possible 6 with 1 dice. So the 2's cancel out, you get 1/6. 1/6 is 16.7%. So question 10. Bag contains 5 red, 3 blue, and 2 green. And it says the probability of getting red and green. It doesn't tell you what order, so we've actually got to work out both. We've got to work out the probability of red followed by green, and add that to the probability of green followed by red. There is a connection. Let's do red first. We know there's 5 red balls in there and 10 altogether. Well, we don't replace it because it does talk about without replacement there in the question, so we can't replace it. That means there's 9 balls left altogether, but we want green second, and there's 2 greens. So we get 10/90 as the first answer. If we want green followed by red the other way around, we know there's 2 green and 10 red balls altogether. But when we take one away, there's only 9 left, and we know there's 5 red balls. We actually get the same answer, so it's 10/90. So the probability of red and green in any order is going to be 10/90 plus 10/90, which equals 20/90, which is 2/9. I think it's 22.2%, that one. Okay, question 11 here, permutation. I've done this one already, but we'll go through it. It's got 11 letters, 5 vowels, and 6 non-vowels. And the question says, find the probability of selecting a letter and getting non-vowel. So it's just going to be the 6, which is the number of non-vowels, divided by 11, the number of letters in permutation. And 6/11 equals 0.545, which equals 54.5%. Okay, question 12, we're choosing a committee. It's quite interesting, this question, because it talks about equal number of doctors and technicians. That we're taking 4 people, that means we must take 2 of each. So we want to find the probability that the committee has 2 doctors and 2 technicians. Well, we know there's 7 doctors, so we're going to choose 2 of them. So 7 choose 2. And, which means multiplication, we've got 8 technicians, and we're going to choose 2. That's how we choose a committee of 2 doctors and 2 technicians. And of course, what we're going to divide it by is how many people are there altogether? Well, there's 7, 8, 15 people altogether. So it's going to be 15, and we're choosing a committee of 4. So that answer equals 0.0266, which if you move the decimal place along 2 space is 2.66% or 2.7%. Question 13 says, game of poker, we want 4 kings. We're dealt 5 cards. What's the probability of 4 kings? So we know there's 4 kings altogether, and we want all 4 of them to be chosen. Well, there's a 5th card. Well, how many cards are non-kings? Well, it's 48, because 52 minus 4, and we want 1 of them. So what we've done here, we've taken care of the 5 cards. There's 4 cards that are kings, and 1 card can be anything. And of course, probability has to be divided by something. Well, how many ways can we take 5 cards from 52 cards anyway? 52, choose 5. And the answer is, so it's 1.84 times 10 to the negative 5, which is going to be a bit of a pain in the neck writing out because it's going to not make much sense. So it's 0, 0, there's 5 zeros altogether, then 184. And we're going to move the decimal place along 2 to get the percentage, so it's in there, which now gives us 0. Don't want too many decimal. Don't want that, do I? It equals 0.0018%. So basically, you've got a very small chance of getting 4 kings in a game of poker. Okay, probability Mary goes to the University of Toronto is 0.35. The probability that she will go to another university is 0.6. Mary goes to university, the probability her partner Taylor will follow is 0.8. So the probability that Mary and Taylor will go to the University of Toronto is going to be 0.6. Sorry, no, it's 0.35 for Mary. And then if Mary goes, there's a 0.85 chance that Taylor will go as well. So 0.35 times 0.85 equals 0.2975, which I think you have to round up. It won't be 297, it'll be 298, 29.8%. Question 15, best done with a Venn diagram. And we've got 2 things here. We've got the kids who listen to teacher and the kids who listen to music there. So we know that the kids that listen to both, 9% listen to both teacher and the music. And the percentage that listen to teacher is 85. So we do 85 minus 9, we'll get 76 who listen to teacher without the music. 20% listen to music, but 9 of them the teacher as well, so it's just 11 listen to music. And if we add those 3 numbers up, so 76 plus 9 plus 11, we'll get 96. And if you do 100% minus 90%, you'll get 4% of the kids who do neither. The probability that, or the percentage probability that they will fail the test because they don't listen to any is going to be 4%.